Hello? 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 Okay. Good afternoon, everyone. We'll start in few minutes. Okay. Hello. So can you hear me? Hopefully I'm audible. We'll start in 1 minute or 2 minutes because waiting for a few more people to join. So this is your tutorial session for week 6 for the course Engineering Mathematics 2. This is Rahuldev Ghorai from ISA Thiruvananthapuram. So we'll start today's question answer by this is the first one, the first question. So if you have a function fx, if you try to approximate that by a quadratic polynomial, then what will be the error, like how much error you will get. So That is about the first question. Okay. So if you have any nice function, nice mean at least twice differentiable, right? Then what you can do, so you have a function fx, you can always write as it's a nice function f0 plus f prime 0x neighborhood of 0, in the neighborhood of 0 you can write like this, plus 0 over 2x square, approximately you can write like this, right? So when we write it approximately, then what is the error we are living? Like this approximation, we are doing something. You have a curve like this. You maybe do small part of this and then this like that. You just approximate it using the polynomial, quadratic polynomial, right? I mean, you have a curve like this, so then you can join you can approximate it using some line also, like this, or you can approximate it using also the quadratic polynomial, right? So of course the quadratic polynomial will give you better approximation, but here's the question is, what will be the approximation error? Okay, so how you calculate that? How you will calculate that? If you have a like 3 points are given, at -1 it is 5, at 0 it is 0, at 1 it is 3. This is what is the interpolation error.
Sir,
This is
original
done.
polynomial, sir.
Yes, yes.
Original function minus approximated function, sir.
Exactly. Original function minus approximate function. So then what will be the, so you are telling it's here, let's say our function is fx, and we approximate it by px, so then error will be fx minus px, right?
Yes, sir.
Yeah. So but then what will be this thing, what will be this?
Sir, no idea, sir.
This is not done in the class, so I just want to know whether it is done in the this type of this formula is done in the class. That's why I am asking. I mean, you can do in some way, but it is whether it
Sir,
is done in the class.
sir,
That is
can you explain, sir?
yeah. We'll explain. So
Yes.
the
I think, sir, it is there, but I was unable to understand, sir.
okay, okay. So what we do in polynomial interpolation, we see. So when you have, let f is a function which is in like f is a function is a continuous and differentiable, all those things you assume, okay, and p is a polynomial of degree less than equal to n, degree is less than equal to n, okay, and at px1 is equal to f of x1,
Yes, sir. All
and
those points where
yes,
certain
we
value
know
of function is known, yes, sir.
at n point we know that they are equal. Now we will approximate by that polynomial p and we will find what is the error, right? Because given that these three are, for this case it is 3 points are given. If it's I am telling about endpoints. Okay. So then, so you can remember, or you can also one can evaluate, one can also prove it. But yeah, so no need to. So you just remember that fx minus px will be 1 over n plus 1 factorial n plus 1th derivative of f at xi x. Okay. So times the multiplication of that n points. So in this case it will be, so let's say degree is n plus 1 and then you have 0 to 0, then yeah, it will be 0 to n x minus xi. This is very easy to find out also. So you just your px will look like this. You just construct a function which will have x naught x1 up to xn a root, and then you can find out all these things. Okay, so you have to construct a function
This is
in
function of, sir.
yes, yes,
Error is, sir, polynomial of degree n plus 1, sir. Error
yeah,
function.
this is a polynomial of degree n plus 1. So degree less than equal to n, sorry, not n plus 1, polynomial of degree n, yes, less than equal to n.
Okay, sir.
So in this case, what are given that, so you have to, if the quadratic polynomial is quadratic, right? Quadratic polynomial. So in this case, n equal to 2, right?
2.
Our
Yes.
case n equal to 2. So when you put n equal to 2, so you need to mainly, they're asking about this one. What will be this? That they are like, what is this quantity? You can see this. This is this type of things are, these four things looks like this only. So when n equal to 2, this will be 3. So what will happen for our case? It will be f3. Sorry, f3 means, I just write like this to make like looking like this, and xi. So this times 1 over 3 factorial also will be there, because n
So
equal to
what
2.
is, sir, Jai?
Xi is a number which belongs to the whole interval. You start with the interval. You want to find approximate the function in an interval, right? Xi is a point between that.
Whatever point we can choose from exercise.
Yeah, a to b. From a to b, there will exist a point. You should not choose. You cannot choose that function, that point. There will exist one point, but that you do not know. They are not asking. That's why, see, that is a xi. That's given by xi.
Yes, sir. Jai is there. Yes, sir. Yes.
Xi is there. Xi will be there. So that xi is here. I just xi x I wrote here. I am writing xi. Okay. So 3 factorial, and then multiplication of all these 3. So in our case, it will be, so how many points are there?
3.
X equal to this point. These are the xi's. Minus 1, 0, and 1. So it will be x minus
X
minus
plus
1.
1, x
So
minus 1.
exactly, x minus 1. So then what will be your answer? 1 over 3 factorial. 1 over 3 factorial times x times x square minus 1.
Square
So
minus 1. Yes, sir.
this is the first question. First one will be correct, right? I think second one also. I think it is same. No, it's not same. It is two derivative. So twice it is not. It's not the answer. So the first one will be the answer. The second, third, fourth, they are wrong, right? Second is wrong because of you have twice differentiation is there. Third one and fourth one also you can see easily they are not correct. So this gives that only first question, first one is correct. You understand this?
Yes, sir.
Okay, okay. So this formula, it is kind of easy to remember, right? If you want to approximate a function, using quadratic polynomial, or let's any polynomial of degree n less than equal to n. I mean, you
Sir,
can,
what
yes.
is the procedure, sir, to find
Pros-
this error term, sir? Sir, can
Uh,
you explain
what is
little bit, sir?
what is the procedure?
Sir, question is, sir, that how to, sir, find this, sir, error, sir?
How to find this is a kind of one theorem, you can say. You can prove it that this.
So, what is the idea, sir? Can you explain little bit, sir?
So that is little longer. So that's why I don't wanted to. So you have to first. I mean, okay. So you have to first maybe construct a function. Let's say wt, which will be from I equal to 0 to n t minus xi. So you started all those points and you would name that function. This is a polynomial whose roots are n. It has n plus 1 roots, right? N
Hmm.
plus 1 roots, and they've had access at those xi's, right?
Yes, sir.
Right. And then you take another function like ft minus pt minus, so it will be a little bit constructive. That's why I was thinking how to put this one. So px
Observe leave
over,
it, sir.
so little bit constructive, and you can show that for a general one it
Okay,
will
sir.
be,
Okay.
so using this, and you take the derivative of this phi function, so which depends on x also. So you can show that this phi x will vanish at n plus 2 distinct points. Okay, so which
Yes,
are
sir.
will be, this phi x of x will be also 0, and all other xi's it will be 0. So maybe, okay, I'll make, like this is, I mean, this class should not be for this proving this one. So I may give you note
Yes, sir. Yes,
maybe.
sir. Sir, no need, sir.
Okay, okay. But a little bit easier to remember, because this is, you will see, this is in Taylor series and all. This is one of the remainder term times that x minus xi is that number of points, number of things you just multiply,
Yes, the
right?
product of those, sir.
Product of those, yeah. So, and that is very general. So p is like n degree polynomial. For n degree polynomial, it will be like this. So for n plus 1 degree, so when you go like 1 or 2 or 3 or 4 like that, you just evaluate this quantity, then you will get the error. Okay, what is the error of that?
So,
uh,
sir, n is, sir, number of points.
Sorry.
Sir, n is number of points where f is defined, sir.
In n will be, so n is the,
Number of
this,
points where value of function is given, sir.
yes, no, that is n plus 1. So when you evaluate, so here you will see, that's why this n is, it is asking for quadratic polynomial, right?
Yes, sir.
So quadratic polynomial means it is up to x square, right? So n
Hmm.
equal to 2, then it will be given that, so n plus 1 points will be given to you.
Okay, sir.
Why? So that's the reason is why, if you want to, it is a small thing. So a plus bx plus cx square. This is a polynomial, right? This type of polynomial you are approximating with this type of polynomial. But for this type of polynomial, to know all the coefficient, you need how many
We
points
need
at least?
three equations.
Exactly. So that too, and this is what you need, the 3 points, right? So that's the
Yes,
reason
sir.
why. So when you have 3 points, mainly you will be asking, people will be asking you to find out for
Quadratic.
quadratic polynomial. You will see, that's why. Okay.
Okay, sir.
But that
Okay.
was the reason. If you can remember this,
Yes,
like
yes.
this way. Okay. So any other doubt from here? I think, okay. No one else is here. People came and joined, so that's why I was. Okay. So then here is another question. So stress approximation theorem. So the theorem, I won't say what is the theorem, but this is the, any continuous function on a closed interval can be well approximated by polynomial function. So is that true? So any continuous function on a closed interval can be well approximated by polynomial function.
This should be true, sir.
Yeah, so that is true. So you have to just remember it. Otherwise, proving it needs rigorous mathematics. So continuous function, any continuous function can be well approximated by polynomial functions. Okay. So polynomial function mean, so any polynomial type of function. I mean, it can be. So can it be piecewise polynomial functions? That also one need to see. Okay, that is one another question. So whether you can approximate by polynomial piecewise polynomial function. Okay, so that is different thing anyway. So but any continuous function can be approximated by polynomial function. Okay, that is Wester's approximation theorem says that. So I won't say anything about that. This the theorem is mathematically precise statement will be. So if f is defined and continuous on AB, then for each epsilon there exists a polynomial px such that fx minus px is less than epsilon. If you take the function space of all continuous function, so you will find we can approximate it using polynomial function. Means f is any function, then you can find some polynomial function. So p1, p2, like that. Then so this pn will converge to that f, that type of thing. I mean p you will find in each small neighborhood f and one p which are very closer. Okay, that is a leap it. So it's a very mathematical thing. So just remember that you can approximate. I mean, how much closer you want, you can get using polynomial, any
Sir,
polynomial.
but this theorem is only true for the closed interval.
Sorry.
Sir, we can approximate as a continuous function by using Weierstrass approximation theorem only on closed interval, sir.
Yeah, closed interval is also important because you will see this if you have a function which is on open interval, if it is continuous, so always not continuous in that closed interval. So some problem might be there. So that is rigorously you can see that in proof of the approximation, like Western approximation theory.
Okay, sir.
Yeah, these are. I mean, this is a good question also. I mean, why it is not true in open interval? That might be a counter example might be there that this cannot be. There will be a function which cannot be approximated by any polynomial if it is continuous on open interval AB, and of course that has to be then that has to be not continuous on closed interval AB. Means at boundary point it should not be continuous, but in open interval it is continuous. Then it might not be possible to approximate by polynomial. So because you will see this, if you have like discontinuity like this type of, so let's say it is 1 to 2. Yeah, sorry, 1 to 2, and like this it is going like this, and then at one point it is like this. So when you try to approximate this, so the error will be much. I mean, you cannot, if you are asking that you want error less than this, whatever the distance here, let's say, make it precise, like this and this. So as a visual thing, what you can see, this, when you are trying to approximate this discontinuity using the polynomial, you will have error, much error. So this error you cannot expect as smaller as you want. So that discontinuity point will have problem, but you prove the like how the why it is not true mathematically rigorously, that I do not know. Okay, I mean at this moment I do not know that why
Okay, sir.
where it will be problem. Maybe there will be one example. I most probably this 1 by x type of function which you cannot approximate using it may or may not approximate. I don't know. I have to I need to check it. Okay.
Okay, sir.
Yeah. So one by x in 0 to 1 interval. So then it will be it blows up. So which is in a small neighborhood. If you want to approximate, then this polynomial function has to also blow up and all this. But polynomial cannot blow up in a small neighborhood, right? It will be if you take any neighborhood that will be bounded, right? If you take any small neighborhood. So those things using those mainly idea, one can prove that this which is a discontinuity, then there will be a problem. Okay, you can check with 1 by x in 0 to 1 interval. You can prove it like that there cannot exist. You start with there exists, then you can find that there does not, there cannot be. Okay. Okay, so and if you are not getting, then you can ask me also later. Okay, so then the next one is, so okay, right? I mean, okay, I mean, you can understand a little bit that
Yes, sir. Yes,
discontinuity will have problem because
yes, sir.
one
1
thing
by
is,
x is good
sorry,
example, sir. 1 by x is good example, sir.
good example, right? But can you prove it just now? It is, I don't see how to prove it just now mathematically, but yeah, we can say it.
Sir,
Yes,
when sir x goes to sir 0, sir, near sir
yes,
0, it will sir, it will be sir unbounded, sir.
unbounded, exactly.
But then sir, px minus qx, sir, we cannot make sir
That is less
smaller,
than
sir.
epsilon, we cannot make. That is
Ah,
true.
yes.
But one can say that px is also going to infinity. That
No, no,
that
px, sir, polynomials are bounded in sir closed, open, sir.
exactly,
Oh,
exactly. So that's what I'm also telling. Yes, I mean maybe we take a, let's say at for epsilon equal to 1, there exists a polynomial. Let's say this is p1x, which will be then less than 1. Modulus of that is less than 1. Mean this is less than -1 to greater than -1, right? Then fx has to be less than 1 plus p1x and greater than -1 plus p1x. Now if you take limit as x tends to 0, so this
yes, sir, it
inequality
will
also
go.
should hold,
Yes, sir, yes,
right? But inside it will be infinity, and that infinity has to be less than some finite number and greater than also some finite number, which is like fallacy. I mean, is a contradiction, right? So that type of thing also one can do, I think. Yes, right.
yes, sir, yes.
Okay, okay. So that's why they keep it in a close
On
interval.
close interval.
Yes, yes. So now this is something easy. I think the forward difference operator and backward difference operator.
Yes, sir.
So you have
First one is sir correct.
used for equally spaced interval, right?
Yes, sir.
So you have let's say 0, 1, 2, and for that you know what is the value of uh, if
Function.
function given. So let's say 2, 3, 4, and these are let's say I, then it will be let's say fi points, right? These type of things will be given to you data correspond to the value 0, 1, 2, let's say 2, 3, 4. Then you need to find what is del fi, right? What will be del fi if you use
Del
the
fi will be sir. Wait, sir. Fi minus Fi minus, sorry,
Uh,
yes, Fi
no,
minus Fi.
what it can be, whatever you said, that is also correct. So forward and backward, right?
Yes,
This
sir.
is forward one.
F of x plus h is equal to, sir, delta of f of x plus is equal to, sir, f of x minus, sorry, f of x plus h minus fx in
Yeah,
terms
that
of
is
h,
for
sir.
forward. But it can be
Yes,
for
sir.
backward also, right?
Yes, sir.
Yeah. So
F
for
of x
back,
minus f of x minus h.
exactly. Fi minus Fi minus one also it can be. It can be Fi plus one minus Fi, or
Yes, sir. Yes.
depending on it is newtons backward and newtons this is forward, right? But those are used for equally spaced interval, of course. And when you take del to Fi, that will be del of, del is forward difference operator in this case. So del of Fi, right?
Fi
That is
plus 1 minus Fi.
Fi plus 1 minus Fi.
Yes,
Now you
sir.
treat this one as a 1
Distributive, sir. Delta is a distributive, sir.
distributive.
Yes, sir.
Okay,
So
also you
delta
can treat
Fi
like
plus
this Gi, right? Then del of Gi, it will be Gi plus
I.
1 minus Gi, right?
Right.
That will be Fi plus 2 minus Fi plus 1 minus Gi is Fi plus 1 plus Fi. That will be Fi plus 2 minus 2Fi plus 1 plus Fi. So this is 9. So fourth one and first one is correct. So you maybe you will see if del to Fi, if this is uh, backward. So then what will be, you might see this will be the first one, or it might be, I don't know, you can check it. So in the case of this one, if I minus Fi minus 1, that del of that will be, what will be that, Fi, okay, it will be Fi minus
Fi.
Fi minus 1 minus, sorry, plus I plus 2, I guess, sorry, I minus 2, I minus 2, right?
Why, sir?
Sorry,
Okay, sir. You have
if I
changed
use
the
backward,
sufficiency.
if I am using backward, this is
Sir,
already
for
correct.
backward, sir, operator is, sir, the symbol is different, na, sir?
Okay, I mean the, it will be like this symbol, right?
Yes, sir. This is
Okay, so
nebula,
that
na?
is okay. Then okay, leave it. But otherwise the formula will be this, right?
Hmm.
Okay, okay. That notation, I no, I'm not used to it, so that's okay. So then this is correct. Uh, okay. So now we come to the data set, and yeah, we'll, okay, yeah, that's backward difference for backward, this is for forward, this is for shift operators. Okay, so you know, right, first this one, del f at xi means
Hmm.
the here x1, it will be is a
Fxi
forward,
plus
right?
1
f of
minus Fxi.
2, sorry,
Yes, sir. Fx2 minus Fx1.
right, so that will be 15, right?
15. Yes, sir.
So which is, but not 19, so this is not correct. So let's see this into of x1.
Fx plus h x2. Fx2, sir.
No, this is not 15. We are doing incorrectly. F of x2 is
That is,
this
sir,
one.
x0, sir.
F of x2. This is f of x2, and this is f of x1. This will be
I0, sir. Yes, sir. X0. Okay, okay.
19. This is.
This is correct. Yes, sir.
Yes. So and backward, if you take, that will be f of x1
Backward, if
minus
you take,
f
sir,
of
f.
x0. That is 15. I mean, both are correct. These two options are correct. These two options are correct. Now if you take E of f of x1, what will be this? You know what
fx2 fx2 177.
f of x2 equal to 177. Okay. Shift mean just you
Yes
shift
sir,
it
one.
one.
Hmm.
Okay. Yeah, also you can see using this also f of x1 plus the difference f of x2 minus f of x1. So that will be again this one. Okay. So now little bit we will be moving so that we will have to calculate now things. So Newton's forward interpolation method. So the actual error in the approximation of 10 0.73 using Newton's forward interpolation method, and the following data are given. You have been given that this at these points you know the only 10x values, but can you find 10 value at 0.73? Knowing at few points you can know about the other points also. So using I mean some approximation of course you have to use, but here it is asking that the actual approximation error in the approximation of 10 0.73 using Newton's forward interpolation method.
Yes sir.
How to do that?
So, sir, error in sir Newton sir forward sir difference sir, forward difference interpolation is p into p minus 1 up to p minus 1 upon factorial. Yes, I know that's a formula.
Yeah, then
Then
so okay, let me write the formula. Formula will be this is Newton's iteration method. So 4 points are there. So we'll use P3 polynomial. I mean P3. I will write third order polynomial, right? So this will be f of x naught plus x minus x naught times. Okay, so del f x naught over the space this h.
sir denoted by p sir, x minus x naught upon h. Then it will be easy sir.
Sorry.
Sir, let x minus x naught upon h as p sir. Then you
Okay.
can write. Yes sir.
What that is not a problem. Like you will see later it will be it will not be x minus x naught whole square. X minus x naught times x minus x1
Over
over h square. Two
factorial
factorial
2.
times
Yes.
that is del 2 f of x naught like this, right? Plus x minus x naught x minus x1 x minus x2 over 3
Factorial
factorial.
3h cube.
Sorry,
Yes sir. This is correct.
right, right.
Hmm.
So now what you need to find P3 at 0.73. So then you need to take tan of 0.73. You can do it in the calculator. Then whatever the things will come, that will be the error. When you need to find actual error, then you cannot use that formula. Otherwise, see, when you have this, then you will have another one more term maybe. Using that you could have done, but in that you will have some xi point, some that other point xi, which is you cannot say what is exactly that xi, right? So that's why when people are asking to find exact error, you cannot use that type of formula. Initially we started with the one right here. So this type of formula you cannot use. Although it is polynomial interpolation, but in this Newton interpolation also, there will be Newton's divided difference interpolation. Newton's forward interpolation, sorry, Newton forward interpolation, there will be also same thing, but you cannot use that thing because you have to find exact error. What is the exact error here? So to find exact error, this will be the thing. So first you do like this, and then you know exact what is 0.73, 0.73. So you know, after knowing this P3 at 0.73, you will know the error. Okay, so little bit calculative, but you can do it, right? So mainly what they do usually, so this is x, this is fx, so then it will be delta fx and delta 2 fx, and that's how people do delta 3 fx, keep on going. So as it's forward one, so at this one it will be this minus this, so it will be 0 point, I think, 42, oh, sorry, I mean first 1,
2, 261.
261, right?
Hmm.
And that's how it will go. And when you come here, it will be again this minus this and this. So that's how you will obtain this del fx at x naught. Mean at x naught mean this is the first point. So whatever the points here you have, those will be coming the here, here, and here. That's all. So it will be easy that case. So you can do it here. So what will be from this minus this? You can just calculate it 0 point something. So you just subtract this and write this, and you will have here also something, here also something, right? So then again you will have here also something, then you obtain here, but we will take only these 3 points, this and this. So then we will obtain the del fx naught, this one and this one, and h we know what is h. H will be is a equal space,
0.2.
right? 0.2, because 0.6 minus 0.4 or 0.8 minus 0.6, whatever the gap, same gap will be there, that is 0.2. So once you know everything, you know p3, and you just calculate the error. So you can try in your home. So P 0.73 will be 0.893 if you take 3 points, and tan of this will be 0.895. So that gives you negative of 0.002. So if you take absolute value of the error, this will be 0.002. That error, because error mean just difference, magnitude, right? I mean, not the product whether it's a negative or absolute value only, right?
Yes, sir.
Okay. Okay, so this was the solution is given to you also. So now we will do Newton's divided difference interpolation method. Then I think we will move to the next part. We will see. This is the using Newton difference interpolation form of the given data. You have to find the interpolating polynomial. What is the interpolating polynomial? Okay. So for all this thing, first of all, you need to remember the formula. Then everything will be very easy. But remembering formula is not easy. At least for me, it's not easy. So P5 in this case, because you have this 1, 2, 3, 4, 5, 6. So then it will be P5, right? P5x will be f of x naught plus x1 x naught x minus x naught plus f of x2 x1 x naught x minus x naught x minus x1. It will keep on going out to, you understand, right? 5
Yes, sir. Yes,
uh,
sir.
4 points. Okay. But in this case, it will be little easier in the sense that when you find f of x naught x1, f of x naught x1, that will be 2 minus 1 will be 1. F of x1 x2, f of x1 x2 will be 5 minus 2 is 3, and f of x1, sorry, x2 x3, x2 x3 will be
5.
10 minus 5 is 5, right? It will keep on going, but what will be again then f of x2 x1 x0, that will be 3 minus 1 is 2, sorry.
Yes, sir, correct.
No, there is a catch. So
Oh,
what
so
will be
there
f of,
will be divided by 2.
sorry?
Divided by 2, sir.
Yeah, divided by 2, that will be
3 minus
1.
1 divided by 2, that will be 1.
Exactly. That's what it's not just that one. So again, this 5 minus 3 over 1, that will be also 1. So x3, x2, x1, that will be also 1, and other things. So then x3, x2, x1, x0 will be 0, right? So other points will be 0. Only you will have up to this f of 3 points, right? P5, so then P5 one can precisely write x is equal to f of x naught plus f of x1 x naught times x minus x naught plus f of x2 x1 x naught times x naught, sorry, x minus x naught, x minus x1, x minus x2, right? And plus 0, other terms will be 0 because it is, we are saying this is 0, other terms it will be multiplication of that term, so it will be 0. So then what we get, it will be f of x naught plus f of x1 minus x naught is, sorry, f of x1 x naught is 1, so this will be x minus x naught, and plus f of x2 x1 x naught, x2 x1 x, that is also 1, so that will be then x minus x naught, x minus x1, x minus x2, and what are the points x naught, x1, x2? 0 1 2, right? So f0 plus x plus x times x minus 1, x minus 2. What is f0 value given to you? Is 1, so that will be 1 plus x times x plus uh, okay, I made a mistake here. This formula will not have x minus x2. When you have up to this, so you will see the symmetry. This is not be x2. X minus x1 up to x minus x1. Yes, x minus x1 means 1. So that gives you x square plus 1. Yeah, see, formula was here. This is correct. So here on one side, right, this was x minus x2. So that won't be there. So then you get x square plus 1. So what we obtained using Newton's divided difference interpolation formula, you have a given data. From there you can construct a polynomial which will approximate this function fx. I mean, we know at all the points what is the function approximately, we know, right? You understand this? So third
Yes,
one,
sir.
yes. So now it comes to Lagrange interpolation method. this one you have to do it. Otherwise, like this one you have to do means you will do, and again I will also do that, so that at least one you do, then it will be okay. Sorry. Okay, I'll write maybe the Lagrange interpolation formula. Okay, that I will write. So it's 3 point, right? So then it will be the polynomial will be of degree 2. P2x will be like this. So for this x, when it is x naught, the other points are x naught minus x2 times f of x naught plus x minus x naught, x minus x2 over x1 minus x naught, right, and x1 minus x2 times f of x1. You can see the symmetry, and you can write the third one also, x minus x naught, x minus x1 over x3 minus x naught, x3 minus x naught, sorry, not x3, x2, right, x2 minus x naught and x2 minus x1 times f of x2. That's all. Whatever. So see, once you know the formula, then things are easy. I mean, then things are easy in the sense that you just put the values and you get the answer, right? And mainly you need to find P2 of 1. P2 of 1. Although they are asking the values of fx at x equal to 1, but P2 is approximating f. So P2 at 1 will be the function value at 1 using Lagrange interpolation formula.
Sir, your first term is not correct, I think, formula. Sir, your
X
formula is
minus
not correct. X
x
minus
minus
there should x zero, sir. There should be, sir.
no,
X
x0 is
minus x
below,
zero
right?
times, sir.
No, below is x0. This is a
No,
polynomial
that is
first.
correct. That is correct, sir. But in the numerator there should be x minus x zero, x minus x1, sir.
That is last term, you see.
The first term, sir.
No, first term it will be like this only, right?
This is correct.
Yeah, it's correct. I'll check once, but correct answer.
Yes, sir. This is correct, sir. Correct.
Okay, then you use this and tell me what is the answer.
Option one.
Sorry,
Option one.
option one you're getting. Okay, let's see whether option one is correct. So f of x not f. So for, see, all the terms will be there. Okay. What is x minus x1? The first term will be x minus x1 means x minus 0 and x minus 2. So x times x minus 2 over minus 1 minus 0 minus 1 minus 2. So that will be 3, right?
Times
Times
10.
10
Yes, sir.
plus
X plus 1 times x minus 2
x minus 2
divided by minus 2
divided by minus 2. That is correct.
times 7.
Times 7. Okay. Plus another term
X
is
plus 1 times x
x
plus 1
times x.
Yes, sir. Divided by 3, 6, 6 times 7, sir.
7. Okay. Then what we need to find? P2 at 1, right?
Yes.
P2 at 1 will be?
Minus 10 by 3
Yes.
plus,
Yes, it will be plus 1.
no, 3, sir.
Oh, sorry, 7 is there also. 7. See, you are evaluating at 1. So it will be 2 times minus 1.
Yes,
So
sir.
minus
Correct,
2,
correct, correct.
7.
Plus 14 by 3.
Wait, so plus 3,
7 by 3, sir. 7 by 3. There is some mistakes. Yes, sir.
7
Correct.
by 3 also, right?
Sir.
So you are now
6.
answering
The
where it
answer is
will
6.
be
Answer is 6.
7 plus 1. Sorry, minus 1. So minus
Minus
1.
1.
7 minus 1 equal to 6. So then 6 will be answer. Okay.
Yes, sir.
You
Yes,
made
sir.
mistake in the last one, 7 by 3.
Yes, sir.
Okay, okay. So these are some calculation mistakes. So you should not do it when it is in the exam, but yeah, that's okay. No problem. Okay, so that's how one can do then. So it's given also here. This is Lagrange interpolation. We have
This
done
same
already.
question, sir.
Sorry?
This is same question, na?
Oh, I see. I have repeated this question. Sixth one. This is sixth. Where is eighth question? Okay, okay. 1 minute. Just write the question. It's not written also. 1 minute. This is not the question because the answer is little okay. Answer is also same. Then it won't be the. We'll do a question, a different question. Question. Okay. 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 Yeah. One another one we'll do. So that is we just leave this one. Let us do this. So points are given like this: x 3, 4, 5, 6, and fx value is given like 3, 5, 9, 3, 3, 2, 2, 9, 1, 2, 6, 0. So backward interpolation polynomial. Find Newton's backward inter formula. What will be that? Newton's backward, Newton's interpolation, polynomial. Maybe the values one can reduce, but yeah, it will be easy. Still, it will be easy. Why you will see. So the backward formula will be 4 points are there. So we start with the polynomial P3, which will
3,
be
sir.
f of x3, right?
Yes, sir. Plus y3, x minus x3, y, sir.
H.
H is there 1.
H will be in this case 1. Okay, that's true. X minus x3, x minus x1. So f of
x2, yes, sir. Divided by factorial 2h square.
del 2 f of x3, same f of x3, like this, and the another one also, the same, how to, the x minus x3, x minus x2, x minus x1
Minus x1.
over, yeah, so it is 2 factorial h square, and that will be 3 factorial h cube. But how do you find this gradient of, I mean, not gradient, sorry, I mean the forward operator, this Newton's forward operator, this one, forward one, this, sorry, backward, this is backward, right? So how do you find out, mainly what I'm asking, f of x3 easily? How do you find del 2 f of x3 and delta 3 f of x, you also need to find out, right? So I mean, you use the table for easy, like you don't need to think about anything. So you just do a table. What will be the table? X is there, f of x is there, right? Then delta f, delta 2f, and delta 3f. I am not writing x3 because x3 will be at those points where it is x3. We are having x3. I mean, this is, if you are like this and you have 3, 4, 5, 6. So x3 is mainly will be coming in this column, right? Okay. So now what is f of x value? You have 359, whatever the values I wrote, that I am writing 332, 291, 260. Now backward. So del f backward, for backward, what will be this value?
332 minus 359.
No. That's why I asked deliberately. This value won't be there. Like you cannot evaluate this value. This value will be whatever you are telling. At this point, it has to be this point minus the previous point, right?
We don't know. Yes, sir.
We don't know exactly. So that's why I asked also. So the second one will be whatever you said. This point will be at this one, it will be this minus this. That will be what? 332 minus 359.
Minus 42.
Minus 27, okay?
Minus, yes, sir.
Okay. And this one will be minus, similarly, minus 41, minus 31. Right? And then it is coming here. What will be this value? It will be the middle of this one, very mostly. So minus 14.
Minus 14.
Minus 10.
The minus 14 will be, sir, below, sir, na?
So plus, sorry?
Minus 14 will be below, na, sir?
Yes, the below, of course, that is true. Minus 14, 10, and this will be then 24. So you know all the values. So minus 41, minus 14, 24. All the values you know, right?
Yes.
Is it correct?
24 will be below, sir. Last.
Yes. But what is x3? Sorry, yeah, we don't need this one. Exactly. That was mistake. We need this one, right?
Last.
This one. x3 is this one.
34, sir. Below, sir.
Sorry?
This is, sir. Last one is, sir. Last one is, sir.
This is x0, x1, x2, x3, right? Correct?
Last one is, sir.
Exactly. So
the
we
last
made that.
line, sir.
I don't understand what you're telling.
Sir, we need last line, sir. Values of last line, sir.
Yeah, in the green line. Green, I made it, right? Now correct,
Yes.
right? So this will be
last entry is, sir, 24, sir.
24. That is correct. That is true. 24. This is 24. But what I was telling, this is this one is this one is this, and this one will be this, right? So once you know this, then nothing else is there, right? And H you know, H will be what? H will be
H
1.
H is 3 for 1.
1. So H is equal to 1. You know all
Yeah.
these three values. You just put it and you get the answer.
Yes.
Okay, so that was the,
Sir,
I would say,
numerical analysis is all about sir formulas, sir. If you know the formula, then you can solve the question, sir.
yeah, not numerical analysis, this interpolation, polynomial, and all these things. But it is little difficult to remember all these formulas. When you just do, you can. When you are just studying for exam, maybe you can just remember, but otherwise you don't remember. This difficult. Actually, this 8 question was similar with 6 questions, so I would say this is the eighth question, question 8, and the answer is also okay. Yeah, you read this question. We'll do so. Where is the ninth, seventh question? Seven, six. We have done question 7. Okay. Question 8 is this. Okay. Yeah, we just do this one.
Sir,
Yes.
error in the trapezoidal rule is given by the formula minus h square upon 12 times b minus a y double dash x bar.
What you were telling, the rule, what is given? B minus A whole square
No,
over
sir.
12
Minus h square upon 12, sir.
minus
Minus h square upon 12 times b minus a y double dash x bar, where x bar is some point in 0, comma 2.
F double bar x bar, where x bar belongs to 0 to 2, right? That's all it is given.
So there is b minus a only, sir, not square. And there is minus also, sir.
I don't understand. What else what else has to be
Sir,
there?
I am telling you, sir, minus b minus a
Okay, that is
times.
I told you, right? This absolute value you take. What is the problem here? You will see this. There is absolute value. Error
So
will be
there
always.
is, so there is not square, sir. B minus a is a single term, sir.
Okay. That is true. That is true. Okay. Yeah, okay. Thanks. Okay, this is correct. So that is the error.
Sir, we can also write, sir, in terms of n as, sir, h cube upon 12 n times y double dash x bar, sir. In terms of the n.
So
Where
let us do, no problem. So only what we do, we have to, this is 0 to 2. How many intervals you need? So let's, if you have n intervals, then b minus a over n will be h. So b minus a has to be then nh, right?
Yes, sir. But where, sir, in trapezoidal rule, we, sir, need, sir, we divide, sir, intervals in, sir, three, we take the three spacing, sir. Like, sir, if we have, sir, x0, x1, x2, x3 points, so we, sir, take integral from x0 to x2, then x2 to, sir, that means the, sir, interval contains, sir, 3 points, sir.
No,
Hmm.
not here. Trapezoidal is not like that.
Yes, sir, yes, sir. This only contains one, sir. If x0, x1, x2, xn are, sir, given, then we take x0 to x1 plus x1 to x2 like this.
Exactly, exactly. When it is given the number of points,
Yes.
according to that you do that. If you know only 2 points, you know b minus a times 1 by 2 times f of a plus f of b by 2. If you know 3 points, then it will increase little by little, it will increase. So mainly if I say the trapezoid will give you the summation of I equal to 1 to n f of xi minus 1 plus f of xi over 2 times del xi, that type. Now, if you have 1 points, only 2 points given, then the summation will be only 1 point. Then, if you have 2 points, you will see that will be del x by 2 times f of x naught plus 2 f of x1 plus f of x2. Right? That is what you were asking. You were telling. That point is
Hmm.
easy. So this is coming from this formula.
Yes.
Okay. Now, as you said, we'll put in this. So error is this, we know. So now we know b minus a times over 12 times what is h? H will be b minus a by n. So b minus a whole square over n square. N is the number of interval which we need to find out, right? N square. So error is less than 10 to the power minus 4. What's the meaning of that? That is less than equal to, it has to be less than equal to 10 to the power minus 4. Sorry, f prime, f double prime x is there also, f double prime x bar, that there, right? So now
Hmm.
this f double prime x
1
bar,
upon x plus 4, 4 to the power 2.
that is always less than equal to, yes, that is less than equal to maximum of x belongs
Maximum.
to 0 to 2 f double prime x, right?
Hmm.
What is f double prime x here? 1 by
1 by
fx is,
x plus 4 to the power 2.
so 2 over x to the power 1 plus 4, max of x belongs to 0 to 2, 2 by x plus 4 whole cube.
Whole square, sir. Why, sir? 2, sir. 2
No,
by 1
because
x plus 4. Yes, sir. Yes, sir.
x plus 4 whole
Correct.
cube, right?
Yes, sir. Yes, sir. This is correct.
Yeah, yes. So that will be maximum will attain at 0, because at 2 it will be
At
bigger
0, sir.
at 0. So that will be then 2 over 4 cube. What is that?
4 cube.
1 over 32.
Hmm.
So actual error here, what you can write that this b minus a over 12 times b minus a whole square over n square times 1 over 32, because that error is less than equal to, so this has to be less than equal to 10 minus 4 also.
Why, sir?
So what is the error? Error actually, error should be this error. This
Yes,
is the
sir.
error, but this error is less than equal to the maximum b minus a whole square over a whole square h square over 12 times maximum of f double prime x bar.
Yes, sir. This is correct. But how you know, sir, that this must be less than or equal to 10 minus
If
4?
this is less than equal to 10 to the minus 4, then this one also will be less than equal to 10 to the minus 4.
Ah.
I have to make this quantity less than equal to minus 20 and minus 10 to the minus 4, right?
Ah.
So a less than equal to b, I know. I
Sir,
have to
but
make
it also
I
can be, sir, less than or equal to some other value, sir, na, sir? Other bound,
which
sir.
which one?
So that value, sir.
So now first listen to me, then I will listen to you also. Okay. So I have to show that I have to give the condition that a should be less than equal to 10 to the power. Aim is a is less than equal to 10 to the power minus 4. But I know a is less than equal to b, right? If I make that b is less than equal to 10 to the minus 4, then this one will also will hold. What's the problem?
So, but this bound will be not, sir, best, sir, na?
But I need that's the error which is less than equal to 10 to the minus 4. That's all. Error is less than 10 to the minus 4. That's all I need.
Okay, sir.
Right. So I understand what is your concern, but this error, otherwise this x bar you cannot, you don't know what is your x bar. That's what that is like
Hmm.
that J point. You do not know what is that.
Yes,
My
sir.
it can be anything. It can be anything.
Yes.
So what you write then? What is x bar? What is x bar? X bar is anything between 0 to 2. So, but that has to be a number. I mean, that is something. By somehow you have to make it independent of all the points. X bar is you do not know x bar. What is x bar? It's arbitrary point. So that's why you do this type of thing to make it. You can do better things, of course, but how we will do that, I do not know, right? But this is how. That's the one way. One way should be this, right? So A I know less than equal to B. Make B is less than equal to 10 to the minus 4. Then A will be
Yes,
also
sir.
less than equal to minus 10 to the minus 4.
Yes, sir.
Right?
Got it.
Yeah. So then what is B and what is A? B is 2.
Two.
A is, so it will be
Two.
2 minus 0 times 2 minus 0 square. So 2 minus 0 whole cube
Two.
over 12 times 1 by n square times 1 over 32 to the 5 is less than equal to 10 to the power minus 4, right? So that implies 1 by n square times 2 cube and 2 to the power 5, that will be 2 square. So 4, so 48, right? So 1
Yes,
over
sir.
48 then is less than equal to 10 to the minus 4. That implies n square has
N
to be,
square 48 greater than or equal to 10 to power 4. No. So
yes,
48 should be,
10
sir,
to the power
below.
minus 4 over 48, right?
No, no, sir. 10 to the power 4 will be, sir.
4 plus 4 plus 4, yes,
Hmm.
yes, therefore not minus 4. So can you calculate this one? Can you tell me what is this? N square will be then greater than equal to,
Sir, we need to take square root, na, sir?
yeah, first n square you tell, then also you can, yeah, you can tell both things also after that also. N is what will be n greater than equal to that also.
14, sir, something.
14?
N is greater. Yes, sir. N is greater than 14 something, sir.
14 point something.
2, 14.2.
Okay. So then what will happen? What is asking?
15, sir. 15.
Oh, then answer will be 15. So n is greater than equal. So n can be 15. One
Smallest
can
value.
take, right? Because n
Hmm.
can be 16 also, but lesser one we
We
will take.
need
Why?
the smallest value, sir.
Yeah, we take smallest. So what would have been the answer if answer was given this 15, 16, 17, 18?
15.
No, all the things will be right, because they're not asking, if it's not asking less number, what is the like lowest
Hmm.
number of
Least.
intervals, right?
Yes.
List is not asking. So that's if it
Yes.
was given 15, 16, 17, 18, then all the answer would be correct, because you
Yes.
have this multiple choice question, multiple selection
MQ.
question.
Yes, sir.
So that's why I'm just telling.
So
So
option is
it,
correct in this case, no?
yeah, in this case option A is correct. So also answer is here. It is given I think. Yeah, calculation is also 14.43 if you check it and
So I actually I took sir under root 48 as 7, sir. So that is why.
okay, the sum such thing. Okay, no problem. But yeah, that's how the answer will be. See, we do like this, and then same thing is. Hello, sorry, I can't hear you. Are you telling something?
Option B is correct.
Option B.
Yeah.
Okay, we will have to check anyway. What you have used? What's the definition of this? A to B fx dx, right? What approximation you have? How what is the formula you have used?
Sir, h by 3.
Okay.
Sir, f of x 0 plus
Yes.
4 times
Okay,
f
then
of
correct.
x1 plus f of x2.
Right? If you have used this formula, then it would be correct, I think.
Hmm.
Okay, so then okay, so what we have to do it this h will be 1.01. You were telling B is correct, right?
Yes, sir.
Okay, 1.01 over 3 times 3.86 plus 4 times 3.90 plus 3.96. That's all right. I don't know why. Okay, so this. Okay, then it is correct. So initially we were approximating curve. Now you are approximating area. Do you understand that there is a difference? This trapezoidal rule or Simpson's one-third rule, they are mainly to approximate the area of the function, right? So that is two different thing. Like in also Riemann sum, you do summation over each area, small area. Here you approximate using the point values. You don't need to do all the point values, but you can up to some error you can find out uh, up to some error you can find out the integral value. Integral value means the area under the curve. Area in this case, area in the portion 1.47 to 1.49 for the function fx, which you know only at this point value. Okay. So okay, that's how one can do it. So if you want, I can give some more problem on this.
Yes, sir.
Okay. So try, so for fx equal to x cube, so question 11, x cube plus 1, a is equal, so you need to find out mainly 0 to 4 f of x, where n is equal to 4 is given using trapezoidal rule. You understand?
Hmm? How can you find this?
How can you find this? What is the rule for
N is equal to
trapezoidal?
4 is given, but what are these points? I can sir,
Point value
I
also.
can take sir randomly, na sir.
No. Point value, sir, you can take from here, right? X cube
No
plus
sir.
1 is
X
given.
x0, x1, x2. I am asking for that sir.
X naught will be 0. X naught is 0 to
x1.
4.
What is x1 sir?
Sorry?
x1.
First of all is 0. Then if you have to use n equal to 4, you have only 4 points, right? Then how we will divide? 4 minus
3.
0 over 4 will be the space h, right? Because b minus b minus a over n equal to h.
Hmm.
So h will be 1. Yeah, then 0, 1, 2, 3. Right. Those are 4 points. x0, x1, x2, x3.
But this the first integral we take from x0 to x2 na.
Sorry?
The first integral in trapezoidal rule, sir, we take I1 as sir from x0 to x2, I1, then I2 x2 to like x4.
No, I don't understand what you're telling. X2 to x4? Why what x4? Where we do it? Where we did?
Sir, in this case, sir, only sir one. There are sir only sir 3 points, so we do not need sir I2 sir. But sir, for sir whole sir integral we need sir. We have to divide it sir in I1 I2 sir. Sir, in that sir, the
No,
proof of this.
tell me what is the rule here? What is the rule here? So the 0 to 4 fx dx using trapezoidal rule, what will be the formula? Del x over 2 or h over 2, sorry. Right? H over 2 times first
3
point f
h
of
over
x.
3. Sir,
Sorry?
h by 3 sir is there na.
No, it is trapezoidal rule. I am telling from you. Long time. It is trapezoidal.
Sorry sir. I was I was thinking that you are asking for Simpson one third rule sir.
No, it is trapezoidal rule. So
Yes.
we can do for interest things. We can do
fx1
it
sir.
for both. You
Yes.
do it for both, and we'll see what is the error we are getting. We can
F
calculate
by
error also.
2 f of x naught plus f of x1.
Yes. So n equal to 4 means x1, x2, x3, x4. It will be x4,
3
right?
by 2.
x4. 2 f of x1, right?
3 by 2. Huh?
F of
Yes, sir.
x1
Yes.
to f of x2 plus 2 f of x3 plus f of x4.
Right.
That what will be that? 1 what 2? What is f of x naught?
G1. 1,
1
sir.
plus 2 times
4.
2 4. 18, 56, 65. What will be this? 5, 23, 89, 4, 154. 154 over 2.
154. 76.
144. No, 154.
154. 77.
No, 144. So 72.
144, 154, sir.
144. 4 and 1 5 and 18 23. 23 and 56 is 79. 79 plus 65 will be 144.
Yes, sir. Yes.
72. Okay, that is we using trapezoidal rule. Now let us also find, because we know, we'll see which one is giving less error. Okay,
Mm.
because we know exactly 1024 fx dx. What is that? Because we know function x cube plus 1. What will be using Simpson rule? Simpson's 1/3. This is trapezoidal. Trape- Trapezoidal. This is Simpson's 1/3. Right? What will be this? H over 3 is will be 1 over 3 times. What is the formula? What we used? Formula the
Y naught plus 4. Y1 plus Y2.
y naught plus 4y1.
Uh,
4 times 2 then plus.
4 times Y2.
Are you sure all will be 4 then?
I think, sir, there should be, sir. Let me check, sir.
I think not. If I remember correctly, most probably it won't be 6. 4 something, some other combination will be there. Yeah. So it will be then 2 times. 4 times the odd one means x1, x3. 2 times even one. And the last
2
one will be,
times.
okay, 2 times f of x2. What is that? You got it, the formula?
Yes, sir. Yes, sir. For even terms, sorry, sir. For odd terms, there is multiple, sir. 4. They are multiple of 4.
Yes. So that's why if
And
this is f of x1, this is 4. F of x2 will
mm,
be 2 times. 2
2
times
times.
what? 2 times 9, right?
Mm,
2 times 9. I mean, as the same one. So plus.
4.
So 4
F of
times
x 3, 10.
56. 4 times 2 times 56, whatever that will be. 4 times. So 4 times 9.
Mm.
No. 4 times 28. Sorry. 4 times 28. What is that?
F of 3, na, we need to, sir, calculate to 28, na?
28. But 4 times 28 it will be.
4 times 28.
112
Mm.
plus 2 times, no, plus,
2 times fx4.
no, f of x4 will be, I think, last one, just as it is.
Yes, sir, yes, sir, right.
65. So now can you please tell me what is the this one? Just use your calculator or something, just tell.
204 by 3.
Okay, 204 by 3. What is that?
68.
Huh?
68.
3 times 6, 68. Okay. See how much error we will see. So 0 to 4. Actual one, what was there? What will be
4
this?
is there, sir.
Huh?
This is x4 by 4 plus x.
So 4 to the power 4
68,
over
sir.
4 is 4
Exact,
to.
sir. Exactly, sir. We are getting, sir, exact value, sir. By Simpson 130.
Yeah, but that won't be always the case. You understand, because that is. I mean, we also don't know why we got 68. Just maybe some wrong mistake we did, or correct. 68 would be the thing.
Yes, sir.
Yeah. So Simpson gives much more in this case, or most probably in the all the cases we will see. Simpson will be there much more better approximation. It will give you much more better approximation. So this area calculation, this might be, these are okay, and this is easy also much more. But these type of things are a little bit difficult to remember and all. Just these are all. But otherwise, these are okay, right? Where I did. Okay, here we did. Yes, these are okay.
Okay, sir. Thank you, sir.
Okay, then today we'll finish our class. So
Okay, sir.
thank you for your attention. Okay, you can go.
Thank you, sir.
And
Okay.